My name is Daniel Freedman. I'm a research scientist at Google Research based in Haifa, Israel. Today I'll be speaking about our paper, Detection of Elusive Polyps via a Large-Scale Artificial Intelligence System. The algorithms described in the paper were developed at Google Research, and the clinical study was performed at Shaare Zedek Medical Center in Jerusalem, Israel. I'd like to describe to you the motivation behind our study, the gap we saw in the field, our approach to dealing with this gap, and next steps. To date, artificial intelligence has shown a lot of promise in its ability to aid in a variety of colonoscopy-related tasks. These tasks include polyp detection, optical biopsy, colon coverage estimation, and others. In this study, we focused on the task of automatic polyp detection using AI. While we examined the performance of our detection algorithm on the entire population of polyps, we paid particular attention to a subclass of polyps which we dubbed the so-called elusive polyps. Elusive polyps are intuitively those polyps which are most difficult for the endoscopist to detect. We identified two types of elusive polyps. The first type, fleeting polyps, are defined as those polyps which appear in the field of view for a very brief time. As we show empirically in the paper, these polyps are very challenging from the point of view of a GI performing a colonoscopy. One can argue that the performance of a detection algorithm on these kind of polyps is a good measure of the true value added of the artificial intelligence. In other words, how much help does it provide on the kinds of polyps which are challenging to many, if not most, endoscopists? This motivated the benchmarking of the performance of our system, deep squared, on exactly these kinds of polyps. We were able to show that the system did quite well. For example, it had a sensitivity of 84.9% on fleeting polyps which appeared for less than 2 seconds in the field of view. We also identified a second type of elusive polyp, which we called a subtle polyp. Subtle polyps are those that not only escape detection by the endoscopist during the procedure, but also by initial offline GI annotators. In other words, subtle polyps are initially categorized as false positives. It is only when they are re-reviewed by new offline GI annotators that they are discovered to indeed be polyps. The deep squared system was able to identify more than 0.2 such polyps per procedure. Subtle polyps are obviously and almost by definition extremely challenging for GIs to detect. They have been missed by both the endoscopist performing the procedure as well as by offline annotators. What is particularly interesting about subtle polyps is that they indicate the AI system's ability to generalize beyond what it has already seen. Let's return for a moment to the general theme of elusive polyps, both fleeting polyps and subtle polyps, as representative of very challenging examples. Beyond our own work, we believe that benchmarking the performance of AI systems for colonoscopy on the most challenging examples is of crucial importance to the field. This applies equally to polyp detection, optical biopsy, and other tasks. Such benchmarks will serve to provide a good measure of the true value added of the AI systems, showing how well they succeed in cases where GIs need the most help. And we hope that our work spurs the research community to focus on such benchmarks. Finally, I'd like to mention another interesting aspect of the artificial intelligence system described in our paper, namely the false positive rate. False positives are, of course, a fact of life for automatic systems. Very early on in the development of our own system, we discussed the number of false positives that would be tolerable with a number of GIs. The consensus from that discussion was that about 5 false positives per procedure would be reasonable. We were therefore motivated to achieve the highest possible sensitivity, subject to the constraint of limiting the false positive rate to such a level. In practice, we were able to achieve a rate of less than 5 false positives per procedure, both on the test data as well as in the clinical study. We believe that a low false positive rate will contribute to a pleasant user experience for GIs. This should be investigated in an empirical fashion, something we hope to do in future studies. I'd like to end my discussion with a quote from Dr. Dan Levovsky, the first author of the paper and also a user of the system. Dr. Levovsky says the following, quote, "As a user, the stability and reliability of the system are impressive. That is, the system is consistent in identifying the same finding as a polyp, regardless of the position of the scope and the direction of the movement, whether forward, backward, or sideways, with very few false alarms. This was especially helpful for elusive polyps that appear in the field of view for a fraction of a second, and that as humans we can hardly see, if at all. When these occurred, the system not only identified the polyp in the first place, but also helped me find it when I pulled back the scope to further evaluate the alert." End quote. I'd like to thank you for your time today.